while ago I created a Rust embedded program that was reading sensor values from a pulse sensor. Viewing numeric values is okay, but it would be far more useful to actually view a nice plot. So I started researching and found some UI libraries that I could use. One of them, and the simplest one, seems to be this Egui library, which even in its demo you can see it has a nice plot widget. And there are more advanced ones, like I found this plotters that can create like really nice and complicated plots. However, to make plotters work, I had to patch a local binary, otherwise it would crash on mouse events. So I figured for an actual easy demo I would go with Egui. So let's go get started. First I will create a new project. Let's call it value plot. And I will add the Egui framework and the underlying graphics toolkit, which is eFrame. At this point we should be able to edit all the programs. So the first step that I would like to do is just make something display on the screen. So in order to do that, I can look at the examples. And this will kind of explain how to get started and go through it. I will use my own copy that I previously recorded and type things a little bit faster. So the first thing that Egui needs, it needs some sort of an application and implement a simple display. And I will do that. Right now I won't keep any values, I will just implement the software display. Unfortunately, my autocomplete is not yet ready, so I'll have to tell my environment to reload my Rust settings. Once this is reloaded, it should be able to do autocomplete properly. Once I save it, will tell me that some functions need to be implemented. Only 2 of them are really required. I need the update and I need the name. The application name is the easiest. Now in theory it should compile, but nothing will be displayed until I actually create an application. So let's do that. And for the display options, I will use the defaults. Now that in theory I should be able to cargo run and some blank screen should display. Let's test that out. You can see completion takes a while. It should be faster in the future. Well, that didn't work well. Apparently I need to do something here. So let's display that empty screen. I will use a central panel. Egui screens have a central widget, and you can decide to place things in a different way. Like they have a top bottom panel, they have a central panel. The central panel seems to fill the entire screen, so I might as well use that one. It needs a context, so I'll give the context a name. And that context is a lambda function that takes a UI as an argument. Let's see if this thing will actually display anything. Trying again. I have a black screen. That's encouraging. Let's try to put a plot in it, just with mock data. I know that eventually I will want to change plot options, so I will put it in a separate variable for now. To test things out, I will display some random line in this plot and see how it looks like. Plots are shown via this plot UI, which has a method for lines and various other things. Like you can see, it's polygon, text. I only need lines, really. The line requires values. Values are a list of points. And I will need to make my autocomplete actually import the real values. And let's use a vector for now. Let's start from 0, 0. And I'll just put 3 because otherwise it will take too long. Let's see if this compiles. Not really, I forgot the initializer, so I have to say this is Y, and the next few ones are Y as well. Well, it seems to compile, so let's try to actually run it. Neat, I have a line. So at this point, I will need to store this line. Actually, instead of being hard-coded, I would like to load it from somewhere. In order to load it, I will create a separate module that's dedicated to storing values. So for this, I will create a new file. And I will call it measurements. And I will tell Rust that I have a separate module called measurements. Measurements will be a structure that at this point I just need a vector of values, and so I will do that. I will use a vectq because I want to be able to efficiently push values at the back, but I will also want to remove at the front because I want to achieve some sort of a scrolling effect from my window eventually. And I will use Egui plot value for simplicity. For these measurements, let's create some sort of constructor. This should be good enough. It says nobody uses it, but I will use it in main soon. My application wants to keep a list of measurements. That's that, and let's implement also an app constructor because eventually I want to add some parameters to the application. Let's see if this still compiles. Excellent, it does. So now for testing only, let's initialize the values in some way. So I'll put the exact same values in measurements. Maybe main, it's easiest. Apparently I cannot yet append to the values. That's fine. I will implement append values here. So I will mutate the values. I get a mutable self, and I will append the value. This should be quite trivial to implement, just self values append. Via pushback. And now in main, I will try to see if it lets me append. Append value, and let's append these. I will change them a bit just so I can see a difference from before. So let's put some big values. And now when I display, I would like to display from the current application. Let's do that. I cannot really access the values, so I will make an accessor. So let's say get values that I will implement later. So in here, let's make a public function get values. And I have to create a new value. And I will create it from an iterator because I can create a value iterator from self.values. This will likely not compile because, oops, let me save again and see the error. It says it found a reference to value, not an actual value. So I'll tell it to just create copies. And I need to return the value. This returns, going in here, save it, node field app. Yes, because self is already an app. I am mutating it because I append values. Let's try to run and see if there's any difference. The values are here, 130 something. So our appending here works. Next, I'm thinking of how the values will be read. I would like to read them from standard input, and the standard input will be a string, and the form will be x space y. This is because this is how my program actually outputs them from the heartbeat sensor. So I'd like to append not a value like I do on line 16, but I want to actually append a string. So let's implement that. This will probably be one of the ugliest string parsing there, but hey, it will work. So let's see, it's a string and it's separated by space. So let's implement that. I'm saying it's a string separated by space, and I will put this in a vector. My autocomplete is a bit annoying. I have the parts. At this point, I really expect only 2 parts. Eventually, if this is fancier, we could make multiple graphs, but I really want only 2. We could add some tracing here, but for now this should be fine enough. And I know that I have 2 parts, x is the first and y is the second or the last, so I'll take them as such. I'm unwrapping because I know there are 2 parts, so I don't need to worry about whether this is actually working or has an error. Lots of unused, but I will use them eventually. And now I want to parse these x's. They are strings, so I want to parse them into floats. Let's do that. Parsing will return either a success or failure, and I will try to handle them the same way. If I fail, I just return. So if it parses okay, I just need the value. If I error route, I will return and fail silently, which is not ideal, but it works. I'm unsure what I did wrong here. Oh, I forgot the match. Okay. I'm matching the parse values, and I will do the exact same thing for y. Except I want y parsing. So I have a valid x and y, and it should be easy enough to add the parts. So let's say self append value x and y. So at this point, if I receive a string, I should be able to append it. So let's see if this works. So I will pass it here 0, 0, and I will pass again different values so I can see changes. Let's see if this runs. It does not. Because I need to pass in a string. Fine. Oh, because I sent the append value. Okay. It's like okay, this works. I have some sort of a graph. This means append string works. Let's go ahead and figure out how to build this and append it from standard input. I want to read from standard input in a thread because iframe run native will run a UI thread, so I cannot read from standard input and run the UI thread at the same time. So I expect to have some sort of thread spawn. I don't want to use OS Unix. I will use std thread spawn, and this will be the method. In terms of how to read from standard input, I will just make a simple loop that reads all the values and will add them one by one. So let's say this is standard input, and then for every line the line is actually a result because I may fail to read from standard input. So match line. At this point I would like to append to app, but this is because this is multi-threading, I will have to add some locking. So I will let it empty for now. And in case of failure, just return, and we're done. Lines is actually in buff read. I will trust my autocomplete. And I will click everything so I don't have as many warnings. This seems to compile, but nothing can append right now because I have two different threads. I have the GUI thread, which tries to get the values, and I have the standard input thread, which eventually will try to add values in here. So what I will do, I will actually say my measurements are reference counted mutex. So sync arc, it should not be here, it should be here. Mutex, you have to be careful because if it goes Egui mutex, there will be weird errors. It's not the mutex that you want, it should be standard sync. And in the new, we will just initialize as needed. So arc new, mutex new, and measurements as before, it's just measurements new. So I have a reference counted thing now. Of course, like now everything needs locking. So get values will happen within a lock. I don't expect the lock to fail, so I'll just unwrap it right away. So this should work as before. And we need a copy of the reference count items, so my thread can also access the same measurements. I'm cloning the measurements, and I should be able to use them here. So and I'm appending the string that I just received. Oh, I don't need these brackets anymore. And this is used now. But this is a string, so I have to make it a reference. And I have to tell that the value is moved rather than just used the move keyboard. So at this point, this IO measurements belongs to the thread and will be freed when the thread finishes. What I expect now is that all the inputs will actually be displayed on the screen. So I have an empty graph and I type a value 1, 2, 2, 3, 100, 10. Notice that nothing happens until I move the mouse, which is slightly annoying. What happens is Egui is an immediate GUI library and it tries to be efficient. So this means it runs this update once, and as long as it thinks nothing else needs to be shown, it will not refresh the display. Any event, like me moving the mouse over the window, will trigger a refresh, but moving the mouse so that you display values is annoying. So I will make this enter a loop, and I will say context request repaint. So this means that every time I say this is some sort like an animation, so keep repainting, this will not peg the CPU 100% because the UI library knows that you have to cap the FPS. So this will probably run at 30, 60 FPS, something like that. So now if I do cargo run, I expect the UI to update even though I don't move the mouse over it. Let's try that. 2, 3, and the line appears. And when I change it, you can see that it kind of updates in real time. So this is quite neat. And what I can even do, I can try to run my heartbeat sensor, which I have it somewhat autocomplete here over here. What this one does is it runs my previous program that has a heartbeat sensor, and it tries to pipe all the input into the current program. I'll place my finger on the sensor and see how it looks like. Now it picks up values, but you can see it keeps going. Like I can see my heartbeats, but this will go on forever and eventually the values get too squished. So I want to achieve some sort of a windowing effect. So for this, I want to set my window size. Let's put here in a pub window size. F64 because it's measured in the same values as we have for X. And I want to pass it in a long. So measurements take a window size, and if measurements makes a window size, the application should take a window size. F64. Let's put here in the window size. And I will not take arguments yet, so I'll just put, how many, 4 seconds maybe? This should compile, but the window size is not used at all. So the way I want to use it is when I append the value. So I just append this value, v, and this means I want to drop everything that I got as a value and is older than I actually want. So let minimum x should be the value.x minus my window size. After I append the value, I want to loop, and if I find anything that is older than window size, I just want to drop it. X is a poor value, so some v. So at this point I have a front. Let's check if it's something that I want to accept. If I don't want to accept it, like it's too old, I will drop it. Otherwise I finish my loop so I can break. This is all great, but you can see that I kind of assume that this thing is sorted. So what happens if somebody gives me a value that is not sorted? And I don't want to think too much about it. I'm thinking if this new value is something that seems out of order, I will just start fresh. This is just a safety. So let's say if I have any value that's less than self-out values, so I know I have last value, and the new value that I received seems out of order, and probably equality is also a good thing to include. I don't want two values in the same plot. I don't know where to put them on the screen. There'll be a vertical line. This is it. So I will clean up the values if I receive values out of order. And going back here, what I expect now is I have a 4-second window. So this program should start scrolling after about 4 seconds. Let's see if that happens. We're at 3 seconds, 4 seconds. Ooh, okay, this is nice. A few things that are annoying, like you can see here, the scaling is a little bit too abrupt. I mean, it works, but it doesn't look pretty. And the other bit is I have a 4-second hard-coded value. I don't want to hard-code it. I want to do command line parsing. Command line parsing is usually done with the clap library, so I will add that to cargo. And for clap, I will want to also derive things. So instead of using this format, I'll use dependency clap. I find this somewhat easier to read. I don't remember the features, but let's look at documentation. So the features are derive. I can paste this, and I will also paste the example because it's easier to change. I will have to to use clap parse. The value that I want the window size. I will just name it window. And I have my arguments. And I don't need to hardcode the window size anymore in theory. I can just say args window. Should be probably public. Result import, it's probably not refreshed. I can run cargo check just to be sure. Yep, it says it should compile. So now cargo run should be able to say help. Clap takes a while to compile. It also has this derive, which is a more complex macro. Hey, I have help, and in the help it says I am allowed to do a window, which is the name of the person to greet, which is totally wrong. Let's update this. That's a poor help, but at least hopefully now it looks slightly better. It does work. And now let's run it with a different window size. I'll use the short value. Let's say 1 second. This will scroll really fast. Oh yeah, it does. So then the next bit that I would like to have some sort of an include value that I always include x in a specific range. This will say this will set a minimum zoom or a maximum zoom. So for this, let's call this include y. And I have multiple values, so all the values that somebody sets here will be included on the y-axis. This means if I set a range, let's say from 1000 to 2000, those values will always be shown on the plot. And because I have these include y, I would like to add it as part of the app configuration. And I will pass them around in the constructor. Everything should compile at this point, except include y is never used. And the way I will use them at this point. So I'll say for every one of these values, plot include y of this value. This doesn't quite work because include y returns a plot. It's kind of like a builder pattern. So I'll make the plot mutable, and now things should compile. Oh, it's pattern matching, so I have to extract a non-reference bit. This works. So now what I will do is I will say include 1000 and include 2500. This means the zoom should not be as severe as before. This scrolls way too fast because I kept the window to 1 second. This is not a good window. Let's keep it to whatever the default is, which is 4 seconds. Program pipe. Oh, do I need a window always? Because I didn't set a default value? Maybe. I'll have to set a default value eventually. Let's do 5 seconds now. So it starts only 5 seconds, but notice when it zooms, it doesn't actually zoom all the way through. So I think this looks quite nice. I'm happy, except that default value made me unhappy. So let's see how we set default values. It's using this thing. So my default value for a window will be, I know this is in milliseconds right now. I'm sure it will be different for every other program. 5 seconds seems to be good enough. Has to be a float. Everything compiles. And let's see how it looks like. And that's it. It's a nice value plotter that scrolls and probably can be extended in the future. I hope you found this useful.